Yep.
Okay, now what if I ask find f of -3? I know it's silly, but I want anyone else to say something.
Sorry, what was the question?
How do I find f of -3?
You plug in -3 for x. Or...
Absolutely. So -3 squared, that's 9. -3 times -3 will be +9, and plus 5. This is 18 plus 5 is 23. Excellent. So the point I'm making here is this, that if I have f of something, this function has a pattern. What is the pattern? Something squared minus 3 times something plus 5. This being the same thing. Now, this was a preparation for f of x plus h. Can anyone tell us how to write f of x plus h? Anyone? Anyone I haven't heard from, please.
X plus h squared.
Excellent. But please say parentheses.
Okay.
Yes, minus.
Minus 3.
Awesome.
Times
Yes, x plus h plus 5. Excellent. Brilliant. Thank you so much. That's all I needed. Now, we discussed this last time. How many terms do I get when I square a binomial? Yes. Can anyone give us those 3 terms? Anyone? Anyone else, please? It's okay if you're wrong. I just want to hear you say something.
Is it x squared plus 2xh plus h squared?
Thank you. Brilliant. Minus 3x minus 3h plus 5. At this point, I can say I have all 3 pieces ready. All I have to do is just put them together and see what happens next. So I'm ready to write the difference quotient. So dq. Watch me run out of room, I always do. I have to copy all this in place of f of x plus h. I'm copying it. At this point, I have to be careful because I have the negative sign to be distributed to these 3 terms, to all 3 terms, not just to the first one, right? Negative x squared plus 3x minus 5. Negative x squared plus 3x minus 5. At this point, I'm going to say stop because there are 2 comments or 2 notes that I have to put in before I continue. Crucial notes, very important notes. Number 1, for any function, when we determine the difference quotient, it is mandatory that all terms without h simplify in the numerator. If they don't, something is terribly wrong. So let's check. They do. Then I move on to the second note. This h from the denominator, must simplify, must go away. But this is the correct order. First this has to happen and then this has to happen. If this doesn't happen, something is terribly wrong. So you will see me do this all the time. It's not because I'm lazy, it's because I don't want to waste your time. I put an equal symbol and I put a circle, or I put a triangle, or I put some other shape, which means This continues somewhere. Please look for it. And it continues here. I see that there are 3 terms left at the top. Do they all have a common factor?
Can you pull your paper down just a little bit? I can't see the equation.
I'm so
Thank
sorry.
you.
Sorry, thank you.
What was the question?
Do they all have a common factor? So the key words always in math are factor and simplify. Do we see a common factor in these 3 terms?
The letter H.
Yes, because it's a common factor, we have to pull it out. That's how step 2 happens. I'm not allowed to simplify before I factor it. Good, but now I have 3 terms. I have to have 3 terms here. Can anyone give us those 3 remaining terms that I have to write in parentheses?
2x
Excellent,
plus H
excellent.
minus 3.
That's it. Step 1 happened. Step 2 happened. This is the final. Done. And you can say, this is the difference quotient for the original function. What does it mean? What is this? What's the purpose of this? And you will see it has an even bigger purpose later on in this class. So, but I still want to explain a little bit. This, when I determine the average rate of change, it just tells us that I drove between these 2 points, I drove with a speed of 200/6 miles per hour. When I try to determine the difference quotient, because these 2 are so close to each other, this is no longer a secant line, but almost the tangent line. Almost. It's not the tangent line because these 2 points are not one and the same, right? So they are close to each other, but here is the rate of change between these 2 points, but here, because they're so close, I'm still drawing a line through them, but because they're so close, this is almost the rate of change between these 2, but they're very close, which means when I drive to New York and you say, okay, you got there, it took you 6 hours, what was your average speed? I'll tell you 200/6. Calculate, and that's what my average speed was. But if I'm here, let's say Wilmington, Delaware, and you call me and you ask me, what are you doing? And I said, I'm driving to New York. And you say, look at your odometer and tell me what is your instantaneous. I'm going to write this down for you. What is your instantaneous at that particular moment? And I will say 55.3 miles per hour. I look at the odometer. I'm safe. I'm not holding my phone in my hand. You call me and you say you're driving. Okay, tell me your instantaneous rate of change or instantaneous speed. And I'll look at the odometer and I'll tell you at that instant I was driving 55.3 miles an hour. So that's the difference between these 2. The average rate of change, it gives us the average between Baltimore and New York. But if you want me to tell you the instantaneous rate of change, that will has something to do with the difference quotient, unless I have the odometer to look at it. So this is the almost, this expression is the almost, the instantaneous rate of change of f of x with respect to whatever this is. If x is in hours and the function is in miles, then it will be in miles per hour. So notice one other very important item. Average speed has two measurement units. Always one coming from the top, miles, from the measurement unit of the top, and one coming from the measurement unit of the denominator. Same thing here. This, for a particular point, will have two measurement units. One coming from the function, from the top, and one coming from whatever we have in the denominator. Always the rate of change, difference quotient, two measurement units. Any questions on the difference quotient for this function? You will see what happens with this next. But this is what we have to do to determine the difference quotient. And the use of this will become very clear a little bit later. But this is almost the instantaneous, almost the 55 miles per hour that you asked me about. The average rate of change is not, because it takes into account that I took a break, maybe I stopped to eat, maybe I stopped for the gas, to fill up gas, and so on and so forth. So that's the average speed. But the instantaneous rate of change is what happens at that instant. Okay, I wanted to, any questions for me, please? Don't let me move on if you have questions, please. Okay, I wanted to talk about a function that is called piecewise defined function. Piecewise defined function, and how to graph it. So let's look at 69. I'm going to copy it, and I'm going to explain everything about it. So it's negative x for x less than 0, it's 4 for x equals 0, and it's x plus 2 for x greater than 0. So this is a function given in pieces. One piece, the second, and the third. It can have 2, it can have 5, it can have infinite. Piecewise defined function. Okay, here's an example for you. The tax code. I don't know numbers, I'm just going to make up numbers. Here's the tax code. If a person makes between 0 and 20,000, pays 0%. If a person makes between 20,000 and 60,000, pays 5%. If a person makes from 50,000 to 100,000, pays 15%. This is an example of a piecewise defined function, the tax code. Okay, what we are asked to find now, or do now, is graph it. We're asked to graph this function. See how it looks like. It's a very important topic in this class, to be able to graph a simple piecewise defined function. Here are the steps. In step number 1, I identify what these mean. What does this mean? Well, obviously it means between negative infinity and 0 in interval notation. X to the left of 0, from negative infinity to 0. This one, there is nothing I can write, it's just x equals 0. Can anyone give us the interval notation for this piece? And I will put it here. I haven't heard from, I think, Mo, Amara, Erica, I think. Anyone? Are you with us?
Yeah, sorry, Professor. Can you repeat that?
Yes. So x less than 0 means the interval between negative infinity and 0. Anyone? What about this? How do I write the interval notation for this?
would it be 0 to infinity?
Brilliant. That's all I needed. Excellent.
Okay, thank you. I didn't even know, sorry, Professor, because I had came in a couple minutes late. I didn't want to just like.
That's okay. It's okay. It's
Yes.
okay. Thank you so much.
All right.
So the first step, I have to find the domain. Looking at all this, can anyone give us the domain of this function? Sorry, I have to mute you so there is no background noise. I'm the only background noise here. So can anyone give us, by looking at this, can anyone say the domain of this function is?
Would it be from 0 to infinity?
So we're talking about the function. So we have to look at all these pieces, everything.
Okay.
Would it be
Would it be-
negative infinity, comma 0 union 0, comma infinity?
But since 0, you're correct. But since 0 is there, I would simply
Oh.
write, yes, negative infinity to infinity. Nothing is missing. This one has everything between negative infinity and 0. This one has everything between 0 and infinity. And also x equals 0 is there. So I would say, awesome, everything. Then I will create this table of ordered pairs. And I will put the domain in. Careful how we proceed. You may be used to other methods. I highly recommend this one, but I accept others. But this is a very simple method if you're paying attention or rewatch the tape. See this parenthesis under 0. See the other parenthesis under 0. So I'm going to put 0 because that's what I have. If I had 5, I would have put 0 and 5, but I will have 0. A left parenthesis to the left of 0, exactly under 0 but to the left, and a parenthesis to the right. And inside, I write 4. What does this mean? When x is 0, the y value is 4. And something happens left and right, but we don't know yet what it is. I will make myself a note. On this interval, I will be using negative x because that's what I have. The function says, whenever x is between negative infinity and 0, you must use negative x. Whenever you pick x between 0 and infinity, you must use x plus 2. Okay, fine. So now I will pick values, different ordered pairs, because this is already done. Remember x and y intercepts, right? So for this, when x is 0, y is 0. Remember, I always look for x and y intercepts. So I just need another value. So let's say negative 1. Can anyone plug in negative 1? Can anyone plug in negative 1 here and tell me the value of y? When x is negative 1, what is the y value? When x is 0, I know the y value is 4. But what about when x equals negative 1? What is the y value?
Positive 1.
Of course. Thank you very much. For a linear function, I have enough 2 points, but I would like to plug in 0. And I know you should say, no, you cannot. You cannot plug in 0 because you have a parenthesis. You cannot plug in 0. Bear with me and I'll explain in a moment. So also plug in 0 here and tell me what you write inside the parenthesis. When I plug in 0 in this expression, what do I get?
Would it just be 0?
Excellent. Leave it alone. When x is 0, y is 4. Fine. Now we are dealing with this. Let's plug in 0. And tell me what you write inside the parenthesis. When we plug in.
Positive 2.
Excellent. And let's find another because this will be 0 at negative 2, but negative 2 is over there. So let's say 2. So plug in 2 and tell me what you get as the y value.
4.
Excellent. Perfect. Now, let me explain what I just did here. 0 the immediate vicinity of 0 will be, I'm guessing, 0.0001. Do you want to plug this in, x plus 2? Nobody wants to. So that's why I will plug in 0, and I will leave this point an open point. Again, 0, 0 will also be an open point because I'm not allowed to plug in 0. But if it's in the immediate vicinity of 0 from this side will be negative 0.000001. Who wants to work with these numbers? No one. So I will plug in 0, but I will leave it open. And this will be the only one that is a full point. That's why we plug in 0 in these expressions, but we leave them open. I will be using 3 different colors to make a point. You don't have to. I will use blue for the left. I will use whatever this color is for the right. And I will use red for the middle, which is this simple point. The reason why I'm using these 3 colors is because I don't want to see a graph like this. Is this the graph of a function? If I graph something like this, is this the graph of a function?
No.
By the vertical line test, is not. So again, what does this say to us? You can only graph negative x only between these 2 values. You can only graph x plus 2 between these 2 values. You can only plot 0, 4 only for this point. You cannot extend anything to the left or right. So finally, I'm going to start with the middle, which is 0, 4. And this is a full point. And that's done. I'm done with this color. I am on the left-hand side, negative 1, 1. 0, 0, open point. Done with this color. I cannot extend anything anywhere because this is only between negative infinity and 0. A full point is only one full point, which is 0, 4. And now I'm using this color for 0, 2. It has to be an open point, and 2, 4. Which cannot be extended to the left. If you extend this here, and if you extend this here, this is no longer a function, it collapses. It doesn't mean anything anymore. This is only for this piece. This blue piece is only for that. And the middle 0, 4 is only this point. These cannot be closed. It will not be a function anymore. Final question, and I'll stop. Can anyone give us the range of this function? So remember, the range is from the lowest y value till the largest y value. What do I write?
Is it negative 1 to infinity?
Careful. Does this line cross the function? No. Does this line cross the function? No. What about here?
It will be 0, right?
But an open point, because it's not a full point.